guys, so I'm going to talk about now the nitration of benzene. So nitration of benzene takes place in 3 steps. The first step is my activation step. So if I think about benzene, benzene has this delocalized electron ring. And what that does is it spreads all my electrons out so that they don't have much electron density. Look, they're all spread out around the ring. So what this means is it's actually quite hard to make benzene react because it doesn't have a high enough electron density to attack anything. So because of that, what we're trying to add on to this is a nitro group, NO2. That's what the nitration is. Because of that, we need to do something called activate my nitro group. And the way we do that is by giving the nitro group a positive charge. By giving it a positive charge, we make my nitro group a very strong electrophile. So even though there isn't much electron density here, it will still be attracted to this because it's got this positive charge. It's a very good electrophile. So this activation step is basically how we generate NO2+. And what we do is we start with concentrated nitric acid, and we add to that concentrated sulfuric acid. And this sulfuric acid is actually a catalyst, and you'll see why by the end. Think to what catalysts do. Do they get used up? So you should hopefully see by the end. And what happens? Sorry, bear with me. What happens is we take my HNO3 and I remove an OH minus. So imagine me getting rid of an OH minus. So HNO3 minus OH minus, that'll leave me with NO2+. So I've got my OH minus in the bank. My H2SO4, that loses a H+. So I've got my OH minus and a H+, they're going to join together to make water. And I've got H2SO4 minus the H+, that leaves me with HSO4 minus. So this is my activation step. Next comes my main mechanism, my curly arrow mechanism. So here is my benzene ring, and I have just made an NO2+. So what's going to happen here? Well, like I've just said, this is a very strong electrophile, so it's going to attract electrons from my delocalized electron ring. So a curly arrow from the ring to the nitrogen. And what's that going to give me? Well, now my delocalized electron ring has been broken. The electrons at the top here, they've been given to that nitrogen. So I no longer have a delocalized electron ring at the top. So that's going to look like this. I always imagine it as a smiley face. But on the exam, on the mark scheme, they're going to have a dotted line halfway down the molecule. And if you don't make your smiley face go past the dotted line, you won't get the marks. So it's not just a smiley face, it's a very smiley face. Very happy molecule. And this carbon here has now made a bond with that nitrogen. So my NO2 is now bonded to the molecule. As this place here has lost electrons, it now gets a positive charge. Because the electrons aren't there anymore, they've been given to the nitrogen. And if you lose electrons, you become positive. So I always imagine that's the smiley face, and the positive charge is the nose in the middle. Now, what I'm going to do now is I'm going to add this hydrogen on. This hydrogen was always there. So I could have drawn it on here. Each of these carbons has a hydrogen. I just didn't bother because the hydrogen wasn't doing anything in this step. Okay, so to clarify, I've not just added a hydrogen on. This hydrogen was always there. I've just drawn it on now to show where it was, always. And then what happens, this ring does not like being broken. It makes the molecule far less stable, which it doesn't like. So it's going to try and remake itself. And the way it does that is by nicking electrons from this bond here. So smiley face is the mouth. Sorry, delocalized electron ring is the smiley face, is the mouth. The plus is the nose, and the arrow is a bullet between the eyes. That's how you get in the correct position. And what's that going to give me? Well, I have now remade my ring. I still got the NO2 bonded to it, and do make sure your bond goes to the nitrogen, not in between. And if I've broken this bond, this hydrogen will be released as H+. This H+, by the way, is the bit everybody always forgets. So just kind of make a mental note about that. And then once I've done that, I can do my regeneration step. And it's the regeneration of the catalyst. So we said earlier H2SO4 is a catalyst, but I changed it into HSO4-. So HSO4- will react with the H+ I've made here, and that will remake H2SO4. So that's why it's acting as a catalyst. If we want to do an overall equation for this mechanism, I've got my nitric acid. I'll rub this off to make some space. My overall equation, I have my nitric acid. I reacted that with benzene in the curly arrow mechanism step. And that gave me nitrobenzene. And in this first step here, I've also made some water that doesn't get used up. So plus water. I started with sulfuric acid, but I made it at the end, so they cancel out. I made a H+ in my curly arrow mechanism, but I use it up here. I made a HSO4-, but I use it up there. And I made an NO2+, but I used it up in my curly arrow mechanism. So they wouldn't be part of the overall equation. The only thing we're actually reacting in the overall sense is benzene and concentrated nitric acid. And they make nitrobenzene and water. Okay? And that is the nitration of benzene.